So this is number 41. So before we do this, let me just give you a quick reminder. Sometimes you learn back in you guys know how to solve equations like that absolute value equations. So when we do this, we got to get the absolute value by itself. Well, remember what the other one looked like. It's multiplied. Right, because if you think about it, what number can I put inside of that absolute value to get an answer of 12? 12 or negative 12. So x plus 5 either has to be 12 or it has to be negative 12. You guys remember doing this? And then you solve those two equations separately, and that gives your equivalent of the two solutions. Right. So, okay, so let's talk about this. We didn't do any examples where we had factors that were inside of square roots or absolute values, but nothing really changes. So just do the same stuff that we did. So what we need in order to create our sign chart is zero. So let's find our zeros. So let's take each of these factors and set them equal to 0 as well. X equals 0, and x minus 2 equals 0. So if I were to do this method over here, I'd split it up. I get two different equations. One would be x minus 2 equals 0, and the other one would be x minus 2 equals negative 0. Still just 0, which is really the same thing twice, right? At the end of the day, my 0 is x equals 2. So 0 and 2 are going to be the two important points on my number. And then we'll split it up and do what we normally do. Got two factors. We'll put that in each of our regions. We'll do plus and minuses. And I'm going to leave the rest up to you. But of these two factors, does any of them have like a shortcut that we could use when it comes to positives and negatives? Is one of these factors always going to be positive? Yes, x minus 2 and the absolute value, that has to be positive because it's an absolute value. So I don't need to do any work. I know that that's going to be positive in all three regions. And then just pick your test point and test the other ones. For this problem, are we looking for overall positive or negative regions? Positive regions. Are we going to include 0 and 2? No, because that's where this side is equal to 0, not just greater than. So I'll let you finish up 41. A little bit different, but same basic idea. So we're not going to go through the whole thing again, but we'll talk about it. So we've got two factors. One of them is 2x minus 1, and the other one is square root of x plus 1. And this time we are less than 0. So same idea. We got two factors. We need to find zeros for both. So I'm going to take 2x minus 1 and set it equal to 0 and solve that. That's going to go on my number line. And then I'm going to take the square root of x plus 4 and set it equal to 0 and solve that. So what would you use first to solve that? How are we going to get rid of the square root? Square both sides. 0 squared is still 0. Subtract 4 from both sides. You got negative 4. So build your number line. Get 1/2 and negative 4 on there. And then pick your test points. Are either of these two factors, do either of these two factors have any shortcuts that might be useful to us? Which one? Yeah, so this one is a little bit tricky because this is going to be positive, but sometimes it's undefined, right? So let's go ahead. interested in the word equals 0. We have two factors. So our regions. And we'll pick some test points and put some values in. So something between negative infinity and -4. How about -1000? Why not? What's that going to give me? If I put -1000 in here, that's definitely negative. And if I put -1000 in here, I'm undefined. So a negative number times undefined is still undefined. This whole region is undefined, which means it's never going to be part of any solution. Between -4.5, I'd probably go with 0. That would give us a negative here and a positive here. Negative and bigger than 1/2. That would be a positive. So which regions are we going to keep? We want the ones where it's greater than 0. So just that region. Well, less than 0. Sorry, so not that. This one. So -4 to 1. We're not going to. That one was a little weird because we have some undefined action going on there. What other questions do you have? Yes. I've heard that one. 2x to the third. Minus 3x squared minus 1 to 0. Instructions say complete the factoring if needed, solve the polynomial using the sign chart. So, do I know any tricks for factoring this? There's that factor by grouping, but I'm guessing it's not going to work for this. So how else can I factor this? Well, we practice factoring polynomials. Yeah, we do a P over Q list. What we did in class is we looked at the graph of it. So I'm not going to go through all the steps here, but those steps would be to graph it, find zeros from the graph. How many zeros are we looking for? 3. So what if we look at the graph and we see an x-intercept that's like between two integers? Those in-betweeners, which what do we have to help us check those? So we could potentially use a P over Q list to help us find those. And if we're missing any zeros, then we're going to need to do some division. We'll have to use synthetic division or long division, your choice, to divide some stuff out, get it down to a quadratic. So, to be honest, though, if you graph this, then you're pretty much done with the problem, because you should be able to just look at the graph and see where is it above 0, so above the x-axis, so where is it below 0. If we had to do this problem on a desert island, we'd start with P over Q list. And we use synthetic division to see which of those potential rational zeros are actual zeros. And the P over Q list would be relatively short for this problem. But you will not have any problems on your test where you cannot use your graphic calculator. So, but it may come out next year. Yeah. I have a colleague, another teacher, whose daughter is taking pre-calc. Anyways, their pre-calc classes is no. What's up? It would take longer. Yeah, for a problem like this, we didn't have a calculator. We'd have to run through a P over Q list. You would get really quick with synthetic division. And there's some other tricks you can use too. So we didn't get into it, but But when you're doing your P over Q list, so the way we would do this, if I didn't have a calculator, I'd make my P over Q list, right? Plus or minus. What are my factors of 6? 1, 2, 3, and 6. And my factors of 2 are just 1 and 2. So I'd pick something to start with. I might start with 1. So remember, when you do this, I'm hoping that this will. Let's see if it does it. Oh, 3, 12, that's 6. That sound right? So we didn't spend a lot of time on this, but remember, when you do this, what I have just found is, first of all, x minus 1 is not a factor. Second of all, 1 is not a 0. But what I have found is that the point 1 comma negative 6 is on the graph. Right? Because remember, you can use synthetic division to find of the value of the function at this x value. That's what the remainder gives us. So I found that 1 comma negative 6 is on this. So let's say later on I tried 2, and I found that 2 comma, I'm just going to make it up. Let's say I found that 2 comma 10 was on my function. What do you know? If 1 comma negative 6 is on the function and 2 comma 10 is on the function, somewhere between 1 and 2, there's 0. So what would be the next thing to try? 1.53 over 2. So there are some tricks to like make it go faster. You don't actually have to try all. How many possibilities would there be? 16 possibilities. All right. What other questions do you guys have for the assignment? Got a little off track there. Sorry. Just in case you're on the or in college. All right, let's talk about their test. Test is on